In this tutorial, we will be looking at the future climate scenarios used in the latest generation of climate models, which contributed to the most recent IPCC report through CMIP-6. To understand these scenarios, we first need to talk about CMIP-6, which is the Climate Model Intercomparison Project, Phase 6. This is a global project where many climate models are used to simulate and understand the climate system. Within CMIP-6, there are over 20 different model intercomparison projects, or MIPs, with their own sets of goals and corresponding experiments. For example, there is a project that focuses on prediction of decadal variability, and there's another that focuses on experiments of interest to the paleoclimate community. But the ones that are most important for understanding climate change in the 21st century are the experiments that fall under Scenario MIP. Scenario MIP considers several scenarios that encompass what Earth's future may look like. So we know that human emissions change Earth's climate, and CMIP-6 contains simulations that include emissions from the end of the Industrial Revolution up to the near present in order to simulate the impacts of past forcing. And while past emissions are important, future emissions will depend on decisions made by the global community in the present. So unlike the predictable laws that govern the physical climate system, the socioeconomic and political choices that contribute to our future emissions are so uncertain that we need to consider a range of scenarios. And for this purpose, CMIP-6 defines a set of shared socioeconomic pathways, or SSPs. And these SSPs differ in several ways. They differ in the total amount and the timing of emissions, and they differ in their land use changes. Shown here in this figure are CO2 emissions over time for the 5 SSPs, ranging from the high emission scenario SSP5 to the low emission scenario SSP1. But for now, let's just look at the two that will be used in this tutorial. First, SSP1 2.6. The 1 refers to socioeconomic scenario 1, which is called Sustainability Taking the Green Road. This is an optimistic scenario where we gradually shift to a more sustainable path. And the 2.6 here refers to the radiative forcing due to greenhouse gases in units of watts per square meter at the year 2100. The other scenario you will see is SSP5 8.5. Now, scenario 5 is called Fossil Fuel Development Taking the Highway, where development and innovation are prioritized at the expense of very high emissions. And again, the second number indicates the radiative forcing, in this case the much larger 8.5 watts per square meter. So in the second part of this tutorial, you will be taking some global averages, which can effectively summarize the response of some variable in a climate model to a given forcing. But to do this, we need to consider the fact that the surface area of each grid cell varies. For example, in an evenly spaced grid, like the one shown in the figure at the top, a grid cell near the equator has a much larger surface area than a grid cell near the pole, and so it should contribute more to the global average. And this basically translates to taking a weighted average based on grid cell area, which we'll see in this tutorial.